You might have heard of a little something called AI. You might even use it day to day. But for most, it's a black box. What does a large language model actually do, and should we trust it? At its core, an LLM is a giant probability machine. It doesn't know facts. It simply predicts the next token based on the patterns it learned from training. A token is a piece of a word. Think of it like a Lego piece. Tokens can snap together and form words and thus language. So what's the big fuss? AI services such as ChatGPT are expensive because crunching those tokens requires massive GPU clusters running 24/7. Every prompt you send costs the provider electricity and hardware wear and tear, not to mention the initial setup costs. Because they foot the bill, they often keep your data. Your prompts are frequently used for reinforcement learning from human feedback, meaning your private thoughts or your sensitive code might be training the next model. In addition, these companies like to stay brand safe. Cloud models are heavily filtered. If you want a model that doesn't lecture you on ethics or refuse a prompt because it's too sensitive, you need to own the model. That's where obliterated and uncensored models come in. Obliterated means the neural weights for refusal have literally been turned down, whereas uncensored is a fine-tuned model that removes the safety guidelines, both of which allow for a more free and responsive model. But how does it work? An LLM predicts tokens through weights and biases. That's exactly what training is. It teaches a model the proper weights and biases to accurately guess how to write that professional email to your boss. Essentially, think of a giant dashboard with billions of knobs. Training is essentially turning those knobs till the music starts to sound pleasant. The weights are the strength of connections between the digital neurons. Essentially, multiplying each of its previous neurons' outputs by a specific weight for that input, summing all these results up and adding a bias, which allows the model to adapt by lowering or raising the threshold it needs to activate that neuron. And finally, passing it through an activation function, which introduces nonlinearity and allows the neuron to decide to pass information along.
I got this!
During training, the model adjusts these weights and biases across billions of parameters. When you hear 7B or 70B, that's a scale of how many knobs a model has. The more parameters, the more nuance the model has. But that also means you need more computation power. We are in the golden age of local AI. Programs such as Ollama, LM Studio, Jan.ai, and MLX models allow basically anyone to use and run local AI on their own hardware. But there's a slight problem. To run an AI, the entire model must fit into memory, not just RAM, but VRAM. Think of RAM plus CPU as a 1-lane highway, and think of VRAM plus GPU as a 16-lane highway, allowing for more cars to move through. This is also why, if a model is 11 gigabytes and your GPU only has 8 gigabytes of VRAM, it spills over into your regular RAM, and speeds drop from instant to 1 word per minute. The RAM speed isn't fast enough to keep the GPU busy, but people are catching on to the Mac advantage. Apple uses unified memory. Your 8 gigabytes of memory is treated as a combined 8 gigabytes of RAM and VRAM. This is used for everything, including your operating system, leaving an 8 gigabyte setup with about 5 to 6 gigabytes of free memory for a model. This makes Macs the current kings of high parameter local AI, hence all the 64 gigabyte Mac minis being sold out. But even if you can't get your hands on a high computing piece of equipment, there's a cheat code. You can't fit a 70 billion model on a laptop unless you quantize it. This compresses the weights. It's like turning a 4K video into 1080p. Yes, you lose a tiny bit of intelligence/clarity, but it actually fits on your hardware. 8 gigabytes seems to be the minimum. If you have a base MacBook or a budget PC with around 8 gigabytes, you can still play the local AI game. Models such as Quencoder 2.5 is a powerhouse for its size, and is one I personally use. And it's not just text. For MacBook users, you can download the app Draw Things straight from the App Store. That allows you to generate images locally. I personally recommend trying the model Realistic Vision, a subset of Stable Diffusion 1.5. But what about coding? AI in coding is one of AI's most useful applications, as seen with Claude Code. These platforms allow you to send your code and a prompt to debug, change, or even build to an LLM, often one of Anthropic's models on one of their servers, which processes your request and gives you an answer. Instead of copying and pasting your code into a chat box, this tool allows you to never even stop coding. A word of caution, a low parameter model won't execute the complex agentic prompts you're hoping it will. To run a successful local agentic setup, it is recommended to have at least a 14 billion parameter model. Unfortunately, size seems to matter in this context, but there might be another solution. My personal favorite setup is an MLX server or an Ollama server, running a model such as Quencoder 2.5 and Continue.dev, an extension in VS Code. This setup allows you to ask questions in VS Code about your code. It's like having a junior developer by your side. Be sure to enable context providers that will act as a RAG, giving your AI a pair of glasses to see your specific files, essentially finding the file and adding it to the chat. It provides context. Without a RAG, the AI is guessing. It's also worth mentioning that your context window will depend on the remaining memory you have. This is called the KV cache. It's how the LLM remembers your conversation. This means your larger model might be as smart as Einstein, but will have the conversational memory of a goldfish. So how do you actually do this? First, download Ollama. Then find a model. I recommend one with tools. Then pull the model. After that, download Continue.dev as an extension in VS Code. And lastly, edit the local config file. Here's a look at my own personal config file. Then simply code the next $1 million app. Once set up, the process remains largely unchanged, with one added step: actually starting the AI before you use it. If you use an MLX server or Ollama, you have to open that server to allow Continue.dev to establish the connection. Without it, it's like trying to use Claude Code, but Anthropic servers don't exist. So how do you balance power with privacy? Yes, local AI seems harder. It requires hardware, troubleshooting, and some patience. Sometimes it might seem easier just to give in and use the cloud's massive compute power. But if you want to protect your data, work offline, or need an uncensored assistant, the effort is worth it. AI makes you more efficient, but you still have to have a specific project. You might need some project inspiration, and I know just the video for you.